All right, so we're picking up here on 11. So this is where we start vectors. All right, so first off, you have to understand the difference in a vector and a scalar quantity. Okay, remember a scalar quantity is just a number value. It can be speed, it can be direction, not direction. It can be speed, it can be distance, okay, but it has no direction. Okay, a vector quantity has both magnitude and direction. That's the difference. So number 11, a car driving 50 miles an hour due east. Is that a vector or a scalar? What's the magnitude? 50 miles an hour. What's the direction? East. Okay, so that has both magnitude and direction. It is a vector. Okay, what about 12? A gust of wind blowing 5 meters per second. Yeah, we don't know the direction the wind is blowing. We only know the speed. So that is a scalar. Okay, now 13 and 14 are asking you for several things. Okay, it's some mixed practice within those problems. We want component form, we want linear combination, and we want the magnitude. We're given the terminal and initial points. Okay, so A is the initial point because it's vector A, B. So A is initial, B is terminal. Okay, and we know the formula for component form from the initial and terminal points is x2 minus x1 and y2 minus y1. So we need to label those. So this is x1, y1, x2, y2. Okay, so I'm going to color code here. Well, I don't want it solid. Let's highlight. There we go. X1 and X2. So I'm subtracting that. And Y1 and Y2. And subtracting those. Okay, the order in which you subtract does matter. You have to go X2 minus X1. So 5 minus -1. Okay, that does turn into addition, so that's a 6. Okay, 4 minus 3. That's just a 1. So that is component form of our vector. Okay, now linear combination. I'm actually going to write this above the instructions here. Component form is when we do those pointed brackets. So we have A, B. A is the horizontal component, B is the vertical component. Linear combination is when with A, I plus B, J. Remember, A and J are the standard unit vector. I and J are the standard unit vectors. So that's linear combination of I and J. And then remember, magnitude is found by doing the square root of A squared plus B squared, the horizontal and vertical components. Okay, or you can do distance formula. You can draw it as a triangle and do Pythagorean theorem. Okay, there's multiple ways there to get your magnitude. Okay, so once we have A and B, what is the linear combination then? 6i plus, and then B is a 1. Do I have to write a 1? No, I can just put 6i plus j. That's the linear combination. Okay, and then to get the magnitude, A squared plus B squared all together under the square root. So that is 6 squared plus 1 squared. Remember, if either of those were negatives, the negatives need to be in parentheses. Okay. So that's 36 and 1, so that's square root of 37. That does not reduce. You can leave it as a radical. Or if this is a free response type question, you would have to type in the decimal value, and we would round to the hundredths. So that would be 6.08. Okay, yeah, it will. If it is a free response in AWARE, the Eduphoria, the online testing, it has to be, it's going to be typed in numerically, so you can only type in numbers. So it will be a decimal. You won't be able to type a radical in. So if it's free response, it's going to be the decimal value. And I'll specify in the problem what place value to go to. Yes, good question. Formulas. Here is the formula chart. Why? There we go. Okay. So this is the formula chart you're going to get. Okay. It has law of sines. And remember, for your ratios, your proportions, it doesn't matter if sine of A is over A or A is over sine of A, as long as it's consistent. They have to be the same, whichever two you're setting up. Okay. So either sides on top or sine of the angle on top. Okay. But it works both ways because when you cross multiply and divide, it comes out the same. Okay. So you have your law of sines. You have both types of law of cosines, the ones where you're looking for a side and the ones where you're looking for an angle, okay? And then for vectors, initial and terminal point, component form from initial and terminal point, component form from magnitude and direction, and just knowing that when it's written like that, that's component form. You have your A value and your B value, okay? To get magnitude from initial and terminal point is distance formula. Or if you know component form, it's just a squared plus b squared under the square root. And then the direction angle is inverse tangent of b over a. And linear combination is ai plus bj. Okay, so that's what you're going to be given on this Unit 4 test. You will not be given this much on the semester exam. I don't get to decide what you're given. It is a district-wide formula chart. I know law of sines and cosines will be on there, but I don't think all this information about vectors will be. So for the unit test, I'm giving it to you. But for the semester exam, I think you'll need to know. Okay. All right, let's look at 14 then. X1, Y1, X2, Y2. So that's going to be 3 minus 2, and then -5 minus -10. So that comes out to 1, and that becomes plus 10, so that comes out to +5. So there is component form. So that means it is I plus 5j. You do not need to write the 1 in front of the I there for linear combination. And then for magnitude, would be 1 squared plus 5 squared. That's 25 and 1, so that's the square root of 26. Okay, if you can't simplify that radical any, so you can just leave it as square root of 26. If it was a free response and you were to give an answer as a decimal, that would be, it's 5.099. So if you're going to hundredths, the 9 rounds up to a 10, so it's 5.10. Some people get confused on that rounding there when you have 2 9s in a row. You can have a 0 in your hundredth spot, and it's still considered to the hundredths. That's fine. Okay. I think it counts it right, but I'm not positive. I'd have to go look at Aware and how they do it. So if there's a 0, just put a 0. I mean, if it says hundredths, I would put something in the hundredths place. All right. So y'all feel okay with component form from initial and terminal point? Okay, the next type of question here is component form again, but from a given magnitude and direction. So instead of telling you the points of the vector, the endpoints of the vector, they tell you the length of the vector and the direction. Okay, so remember component form from magnitude and direction, it's magnitude times cosine of theta, and then magnitude times sine of theta. That's to get your horizontal and vertical components there. So this one would be 15 cosine of 75 and 15 sine of 75. This one would be 25 cosine of 100, 25, oops, I wrote cosine again, sine 100. Okay, so these become calculator questions. So if I plug in 15 cosine of 75 and 15 sine of 75, I'm rounding to the hundredths, that is 13.83 and negative 5.82. You get something else? If you're in degree or radian mode. I'll look at your calculator in a second. All right, and then the 25 cosine of 100. Oh my goodness. I'm in radian mode, y'all. That's my bad. Oh, good catch, Cassidy. Is this the first one we've, oh my goodness. Did I hope I didn't do the whole first page in radians. Nobody in the other class said anything. I did the whole first page. I'll go back and check. Well, nobody's done any and been like, oh, I got something different. Well, I haven't posted it. I'm not going to post it if it's wrong. Okay. Oh, boy. Lesson learned. Look, life lessons. Make sure you're in degree mode. All right. 15 cosine of 75. 15 sine of 75 is 3.88 and 14.49. And then let's see, 25 cosine of 100 and 25 sine of 100. And you know what? I should have caught that anyway. 75 degrees is quadrant 1. These should be coming out positive, right? Quadrant 1, it should go right and up. So you should double check just logically. Does that make sense? So yeah, let's use logic. Good call. Now, 100 degrees is in what quadrant? 2. So this should be negative positive, right? All right. So that's a good way to check your work. Yes. Yeah. Okay. We didn't have any that we just did that used sine and cosine, did we? No? Okay, so we're good with those. All right, I'm gonna have to go check it at lunch. Maybe redo that video, we'll see. Okay, all right. Here we've got 3 vectors given in component form. Okay, we've got some scalar multiplication and then some addition and subtraction of vectors. Okay, so anytime you've got an expression like this, I'm going to write in my vector. So vector Q is -2, -3, minus, and then vector P is 4, 0. I'm going to do the scalar multiplication first. That has to be done first. So this vector Q is being doubled. It's being multiplied by 2. So that becomes -4, -6. And you are still subtracting the vector 4, 0. Now you combine with addition or subtraction, whatever the case is. Here it is subtraction, like components. So the horizontal minus the horizontal, the vertical minus the vertical. So that comes out -4 minus 4 and negative 6 minus 0. So there is your solution. You could do that. So if we did that, it wouldn't change our answer, because if we distributed this as a -1, this vector would become -4, 0, but then this would be a plus sign because you distributed the negative. It's gone from there. Does that make sense? So yeah, when you combine it at the end, it still comes out the same. Good question. Okay, so that same thing can happen here in 18. So let's look at that. So we've got vector t minus 3 times vector p plus vector q. So like you were saying, I could distribute just the 3 and this would remain subtraction, or I could distribute the -3 and this would become addition. And I think in this case, it might be better to go ahead and distribute the negative and make it all added together. That might be easier. So the -3 times the 4 and the 0. So that's -12, 0. So that means now that is all being added together, because I already used the negative, the minus that was there. So now that horizontal components are all being added. That's -4, -12, and -2. That's -18. And then the vertical components, that's 2, 0, and -3. So that's -1. You okay with that? All right. Next up, converting some of these angles. Okay, so again, we did this on the quiz. We went over the quiz corrections yesterday, and there's going to be some like this on the test. So you need to know the difference in your direction angle with the horizontal, a true bearing, and a quadrant bearing. Okay, so remember, I'll try and color code here. Let's use green for the direction angle with the horizontal. So this is the only one that's given as a direction angle here in 21. Okay, a true heading is from the north. This one's given as a true heading. And then we'll do quadrant bearing in pink. This one's given as a quadrant bearing. Okay, so we're given the angles in the 3 different formats. Okay, so direction angle is with the horizontal. That's like standard position, what we normally draw and measure angles in. Up to this point, that's all we've been using. And then quadrant bearing is from the north or south to the east or west, right? And so it's got to be between 0 and 90 degrees, because a quadrant is only 90 degrees. It's got to be somewhere between there. A true bearing is from the north, and it's clockwise. The direction angle is from the positive x-axis, or the east, if you want to think of it that way. Call it 0 degrees. And it goes counterclockwise. If it goes clockwise, it can still be a direction angle, but it would be negative if it went clockwise, right? We know that. Counterclockwise is a positive. Clockwise would have been negative. All right, so let's start with that one that we're given the direction angle is 172. So what I need to do first is figure out, well, what is the reference angle here then? Okay, so if this is 172, I know this is 180, right? So what this direction angle, or excuse me, this reference angle is 8 degrees, isn't it? So I'm going to use that to help me get my true heading from the north clockwise to this vector is going to be 1, 2, 3 quadrants. So that's 270 plus that 8, right? So that's 278. As a quadrant bearing, I have to go from the north or south. So if I'm in quadrant 2, I'm closer to the north, right? And is quadrant 2 to the west or east? Yeah, this is west over here. So it's north, okay, to the west. Now, if that little piece is 8 degrees, what's this piece that I drew in pink? Yeah, because the quadrant is 90, isn't it? So 90 minus 8, 82. So we would write that the degree goes in the middle and it's from the north to the west. It's northwest. Quadrant 2 should always look like northwest. Quadrant 1 is northeast. Quadrant 4 is southeast. Quadrant 3 is southwest. Does that make sense? Because this is north, south, east, and west. If you're in quadrant 2, it's always going to be an NW, northwest. This is the northwest corner. This is the northeast. This is the southeast. This is the southwest. When you're doing your cardinal directions there. So those are the two conversions for that 172-degree angle with the horizontal. Let's go back up to these. This one is given as a true bearing of 173. So from the north, it's 173 degrees clockwise. I can do a couple of things here. I can find this small acute angle right here, which would be from the south, right? Going here, is that going east or west? Going east, okay. What would this small angle be? If this is 173, a semicircle is 180, right? So what is this? 7 degrees there. So this would be 7 degrees east of south. Now, as a direction angle, an angle from the horizontal, we start at the positive x-axis and we go counterclockwise around to it. Now I know that little piece is 7, and I went 1, 2, 3 quadrants. I know that's 270 plus 7, so that is 277 as a direction angle. Okay. Now this one is given as a quadrant bearing. So this angle where the arrow is 59 degrees. So what does that mean this reference angle here is? This is 59. What's this piece? Because the quadrant's 90, right? Okay. So from the x-axis to that vector, it would be the 180 plus the 31, right? What would that be? To 11. Good. Okay, and then we need the true heading. So that's from the north, clockwise to the angle. So that angle, the acute angle here, the quadrant angle was 59. So the true bearing would be 180 plus the 59, right? So what would that be? Mm-hmm. 239. Okay, if you need to be jotting down to the side what we're doing, we did 180 plus 59 to get this. We did 180 plus 31 to get this. Like, that's fine. Show that work. Okay. Are y'all understanding the different measures of angles? Now, as a reminder, again, when you are entering theta to do magnitude cosine theta or magnitude sine theta, it has to be the angle from the horizontal. It's got to be the direction angle, this one in green on these, okay? So far, so good? All right. Here, we want to determine the magnitude and direction of the resultant vector. So I'm going to sketch this, what it says. So due north, 100 meters. So I go up 100, and then south, 350. So aren't those just going to, part of those going to negate each other? So I went up 100, and then I went down 350. What is that going to give me? So 250. Now, it's negative 250. That's because it's going down, right? So they want the magnitude and direction. So that's 250 is the magnitude. And that was in meters. And if it's going down, what direction is it? Yep. So we went up one. Oh, it doesn't matter what direction we went first. If we went down 350 first and then up 100, the distance would be the same, but the direction would be different. Because remember, your resultant vector connects the initial point of the first one, so the beginning of the 100, to the end of the second one. So that resultant is going down, so it's going south. If it had been the reverse, it would be going up. The 250 would be the same. So think of it as you physically walking somewhere. Okay, so you're on a street and you go 100 meters north, and then you turn around and you come back 350. So you pass your starting point, right? And go 250 in the opposite direction of the starting of where you went initially. Does that make sense? Okay. Now, some of them are simple like that. Some of them may, create a triangle. Some of them are a little tougher. Some of them might create a right angle and you have a right triangle. So it just depends on what we're given. So that's why I always sketched up. So 17 miles east, so that's to the right. And then 16 miles south, so that's straight down. So my resultant vector from the initial point to where we ended up, this is what I need to find. So this one is not as straightforward as that first one, right? Okay, so I need to know, I know that this is a right angle. If I'm going east and then south, that forms a right angle. So this is a right triangle. So for magnitude, I can do Pythagorean theorem, right? Or you can think of it just as component form. The horizontal component is 17, the vertical component is negative 16. Okay, but we calculate this to get the magnitude. So the square root of 17 squared plus 16 squared comes out to approximately 23.35. And this is miles. Okay, now the direction we've talked about. If I want this angle here, this direction, because this would be quadrant 4, wouldn't it? East and then south, because it's positive and then negative, right? So it's going to come out negative, or I can add 360 to it to get it as a positive, right? Now, it doesn't specify how to give the direction, so I'm not going to be picky on this one. But I would do opposite and adjacent. So I'm doing tangent. Remember, to get your direction angle, it always ends up being inverse tangent of B over A. So that's the 16 over the 17. Now this one is negative because it is down. So that needs to be negative 16. Does that make sense? So you do need to understand that going south means this is a negative movement in terms of the vector. It's always going to be tangent, yeah. Okay, so this is, yeah. I'm in degree mode. Make sure that's the case. Inverse tangent of negative 16 over 17. And that's negative 43. And we're going to round angles to the nearest degree. So 43 is it. So approximately negative 43 degrees. Now, if I want it as a positive angle, I just add 360, right? Okay. So if I do negative 43 plus 360, that's actually closest to 317. So 317 degrees as an angle with the horizontal. So there's my magnitude and direction. So sometimes they're opposite directions. Sometimes they form a right triangle. This one says 15 newtons forward. So that's forward, we'll say to the right. Okay, and then from there we go back 25 newtons. So we went forward 15, then back 25. So the resultant would be here, right? Y'all agree? So what is the length of this resultant? The length is 10. Now it would be negative because it's to the left. So we would we'll use the direction that they're giving, which is just forward and backward. So it's going to be 10 newtons backward. If they wanted it as an angle, what angle would that be? 180. Okay, it's to the left, directly to the left or west. That'd be 180. Does that make sense? All right. I'm going to stop this video here. I'll do the word problems in a separate video.